I would like to welcome everyone to our webinar today. This is the second of two webinars on new SEI tools to support integrated climate and development planning. I have with me today three SEI experts, Charlie Heaps, Chris Malley, and Eric Kemp-Benedict, who have all been essential in developing these tools and who will be available at the end of today's webinar to answer questions, and they'll tell you a little bit more about the tools and their development. For today's meeting, I just quickly want to show you the agenda again that had already been shared with you in the email. We're going to first do an introduction generally on the benefits of integrated climate and development planning. And then I'll give an overview of the new toolset, which consists a macroeconomic extension for LEAP, the FOLU tool, which allows assessing climate mitigation benefits and other sustainable development benefits from forestry and land use, AgHealth, which helps assessing health, climate, air pollution, and environmental impacts of food production, and the new SEI Africa Model, which is a continental-scale model for Africa built in LEAP. And we'll then have 20 to 25 minutes for a Q&A and open discussion. You can pose your questions. This is a pretty big webinar, so the chat option won't be available, but you see the Q&A option in the bottom, and we invite you to ask questions throughout the presentation and as well as during the discussion section. We will go through those questions and raise some of them, and you'll be able to speak up and ask your question yourself. And other questions we will answer in the chat, and everyone will be able to see the answers to those questions. And so we hope that we'll be able to provide quite a nice overview of these new tools. And with that, I'm going to get right into it, since we only have about an hour. I am sure that given the attendance that we've been having in these two webinars of overall about 300, or a little bit over 300 people, many of you are familiar or have a good sense of why it would be necessary integrated planning for climate and development. But nonetheless, I just want to kind of talk about the reasons for why it is really useful to conduct integrated planning to begin this webinar with. As we all know, rapid and decisive action is required to limit global warming to 1.5 degrees Celsius or 2 degrees Celsius, depending on the report that that you're following. And at the same time, we're also trying to achieve the Agenda 2030 and its sustainable development goals. So there is really a need to act quite rapidly on both of these agendas, or both of these conventions. And yet there is a substantial risk of trade-offs between pursuing stringent mitigation action and development. And this has really been highlighted by many different analyses, including the IPCC special report, and areas in which such risks of trade-off are particularly substantial, or in the area of poverty and the reduction of poverty, the eradication of hunger, the availability and access to clean and safe water, and access and availability to energy. And so there is really a need for integrated climate and development planning in order to both maximize potential synergies between achieving the sustainable development goals and achieving substantial climate mitigation at the same time. There is a question of resource efficiency, and we live in a world where resources aren't unlimited, and we have limited financial and political will. And so focusing that on areas where we can achieve the greatest benefit is extremely important. And then finally, to avoid and minimize negative trade-offs that might occur by pursuing climate mitigation, for example, at the cost of sustainable development. This is from an analysis that SEI carried out a couple of years ago. It's called the SEI 2030 Agenda Compass Analysis, and it looked at historical data and expert opinions to identify how synergies between different sustainable development goals really played out. And so the question that it was asking is, if you made progress on a certain sustainable development goal, sustainable development goal X on the left axis here, how does that affect the odds that you also made progress on another sustainable development goal? And what this analysis found is that for certain sustainable development goals, there's really a positive correlation. Pursuing one tended to raise the odds of also making progress in the other. Whereas for other sustainable development goals, there was a likelihood to lower the odds. And so what this analysis found is that progress on SDGs 8 and 12, responsible consumption and production, and decent work and economic growth, were correlated with a greater likelihood of progress on affordable and clean energy. And you can also reverse this and think the likelihood of or the progress on affordable and clean energy and climate action increase the likelihood of also making progress on responsible production and consumption in these. And so as we were thinking about what would be required to really support successful policy action that integrated climate and development planning, we were thinking through the different dimensions that such tools would need to fulfill in order to really be useful tools for planners and policymakers. The first and a very important one is whether the tool only considers historical data and policies, or whether it can actually analyze potential future policies and scenarios. Because the purpose of such tools would be to do forward planning, devise new policies that improve sustainable development outcomes, for example. And so it was really required that a tool that would be able to support integrated climate and development planning was prospective. The second question was that of methodology, namely whether the tool provided qualitative outputs or quantitative outputs. And we thought that it's really important, and I think that's why LEAP has been such a successful energy systems planning tool, is that the output is quantitative, that it really allows to, in quantitative terms, compare what a certain policy can achieve compared to an alternative policy or a policy of a different. The third one is the exploratory power, whether the tool can compare different possible planning decisions, or whether planning decision kind of like would be the case in a historical tool, is simply looking at a given policy and telling you whether it improves or lowers the probability of a certain outcome. And then fourth, the question of accessibility. I think many in the room would agree that it's very important that in order for a tool to truly accomplish what it's intended to do, it's really important that the tool is actually freely available and doesn't require payments. And then the final dimension that we were looking at was that of policy coverage, whether tools analyze both SDGs and NDCs for both climate goals as well as other sustainable development goals. And so as we were looking across the landscape of different existing tools, we were finding that these tools really leave gaps for integrated planning. Many of them are only retrospective, they're only including historical data rather than really being able to support future policies and scenarios. Many were qualitative rather than quantitative, making it difficult to compare different policies. And then finally, the ability of use the tools in kind of a dynamic fashion devising their own policies was often also limited. And then in addition, there were questions about proprietary, whether the tool was proprietary and what different policies could actually be evaluated. And so the integrated climate and development planning research at SEI really tried to fill this gap by focusing on developing and applying quantified prospective impacts of climate change mitigation on SDGs. And a key outcome that we were hoping for in developing these tools was to support planners and policymakers, increase synergies and reduce negative trade-offs between climate change mitigation and other sustainable development goals. And also that we would concentrate the development of such tools in areas that would often be worked. And so some of the areas that we identified were SDG 2 on zero hunger, SDG 3 on health, SDG 5 on gender equality, education, energy. There's quite a list. And it was important to us that people that were already using LEAP would be able to quantify impacts on SDGs in areas that have this greatest potential for risk and benefits. And what the tools allow is that impacts can be evaluated across energy and emission scenarios in NDCs and long-term low emission development strategies. So really supporting users of LEAP in particular that were already using the software to develop low emission trajectories to make decisions between different policies that are maybe initially primarily aimed at mitigating climate change, but ultimately can contribute or negatively affect other sustainable development goals. And so we identified 4 areas where such tools would be most helpful and would provide the greatest return, essentially. And those 4 areas, impacts from forestry and land use, interactions between agricultural policies, health, and climate, air pollution, and health interactions. And to address these 4 areas, 4 tools or tool sets were developed. The first one, AMES, which really looks at energy and energy systems planning and its feedbacks with the economy. The FOLU tool for forestry and land use, AgHealth for agriculture and health, and then the Africa Model, which uses some of AgHealth to look at it. So to begin with, I would like to start with the LEAP AMES model, which is really intended for modeling economic feedbacks in long-term low-emission planning. AMES stands for the Adaptable Macroeconomic Extension for Sustainable Losses and is an open source macroeconomic model that plugs into directly. And so it's really designed to provide consistent economic drivers to LEAP, and in this LEAP and AMES form kind of a hybrid energy economy model. AMES is a multi-sector demand-led structuralist model. It covers all important sectors of the economy, and it's demand-led in the sense that it is driven by investments that are simulated in the energy systems model. It simulates feedbacks between energy policies and the rest of the economy, realistically capturing economic costs and benefits of often quite drastic energy transition scenarios as we're kind of looking out into really low emission futures, including net zero pathways. And the focus of the software is really on low emission development strategies and low incomes. You can find more descriptive information on AMES under the link that is here below. And I just want to add, we will be publishing a recording of this webinar shortly on the LEAP website and possibly also on the SEI website. And as a registered participant of this webinar, you will be receiving a follow-up email once that happens. So you will be able to access the recording and the slides there as well. The motivation for developing AMES was that economic projections drive energy demand and supply in low emission planning scenarios, but also at the same time, these low emission policies transform the energy system on one hand, but with them the economy in which they exist. So there are these very important feedback mechanisms, especially when we talk about decarbonization, energy transition, aren't usually captured in a standard LEAP model, and as well many other energy systems models where traditionally the economic activity levels are specified externally. You specify GDP or sector value added, and that drives your demand. But the energy investment that is required to cause this energy transition, which is already calculated by LEAP, contributes to GDP, but that's not taken into account in a standard model usually. In the LEAP AMES hybrid model, however, there is really a two-way link that is being created between the energy sector and the investments that are necessary to drive energy transition and the rest of the economy. And the economic activity levels are now not externally specified, but become simulated. Energy investments contribute to aggregate demand, and then LEAP and macro and AMES are run iteratively until they converge. The logic functions essentially in that AMES initially passes economic activity levels to LEAP, which then drive energy demand. Energy demand is supplied to the energy transformation, which then supplies the necessary and produces the necessary energy. And that has certain costs, and this investment demand is fed back to AMES. And then the process repeats until the two models converge. As I mentioned earlier, LEAP AMES is open access, and it can be accessed on its GitHub website, to which I have the link here at the very end. I will also show a summary slide on where you can access these tools. So you'll be able to take a screenshot or a photograph of that in the meantime to already look at these pages. Otherwise, you'll also get those links once the recording is uploaded and becomes public. With that, I want to pass on to our second tool, the FOLU tool. And the FOLU tool is really for integrating forestry and land use change into low emission pathways, and then to evaluate other additional sustainable development effects. Forestry and land use change produce in many countries greenhouse gas emissions. In fact, there are key greenhouse gas emission category. Here on the right-hand side, I'm showing annual CO2 emissions from land use change for 2021 from our World and data. And you can see that while some countries in green, in shades of green, land use change and forest as a carbon sink, there are many countries around the world for whom land use and forestry are actually a source of emission. And at the same time, land degradation also threatens economic livelihoods, air quality, water quality and abundance, ecosystem resilience, biodiversity, and many more endpoints. And so in that sense, land use management strategies can be key to climate planning, namely in order to turn forestry and land use from a net emitter into a net sink, but they may even be more important for other development goals. And the FOLU tool is really intended to provide a possibility to forestry and land use management policies. It supports the quantification of climate benefits from land use management policies such as input forest management, including wood extraction, natural forest growth, and reforestation, and forest fire management, as well as other land use changes such as land restoration, for example, of prairies, improved soil management, changes in agricultural practices, as well as livestock management and pastoral practices. And so there are very many different land use policies that can be analyzed with this toolset. The FOLU tool follows the updated 2019 IPCC methodology for GHG inventories. And it uses the tier 1 gains and loss method, which is based on land use changes and requires relatively little data. Much of the data that you can use to employ this tool is available on FAO, on the FS. And so while it can be used to increase resolution and supplement this data with increasingly detailed data if they're available, it doesn't have a super high data requirement. And it accounts for carbon emissions and capture based on land use changes from a variety of different processes, including carbon stored in above and below ground biomass, carbon stored in litter and dead organic matter, and as well as carbon stored in soils. And it does this for all of the key IPCC land use categories. You can see them here on the right in this model schematic, which include forests, agricultural lands, grasslands, settlements, as well as other lands. And as inputs, as I said earlier, you primarily need surface areas by land use, which is data that can be which doesn't exist at the national level, and then land or policy instituted conversions between different land uses, as well as kind of historical transitions, like data on historical deforestation or forest fires, for example. And then it also uses data on wood extractions to calculate the net change in the carbon pool. And so this tool set really enables planners to explore climate and development potential of forestry and land use policies in long-term low emission planning scenarios, but then also allows for the integrated planning from these land use policies through analyzing adjacent ecosystem services and biodiversity goals. And so this tool was, for example, used in the development of Zimbabwe's NDC revision, where it was used to, on one hand, calculate the climate mitigation benefits, but then also to look at the sustainable development goals and specific targets. For example, here, reductions in deforestation and increases in reforestation of land. You can see the reference value for 2017 in the first of the three columns, and then the baseline value compared to the mitigation value. So the achievement of, or the approach of that sustainable development goal was quantified, and then also that the impact that change in land use management would have on biodiversity for different animal groups. And so it really allowed to kind of give an additional dimension to mitigation. With that, I'm going to turn to AgHealth. This is our third tool. AgHealth is intended for integrating analyses of agricultural production and linking them to health benefits into climate change commitments. AgHealth is a tool set for quantifying greenhouse gas emissions and air pollution emissions from livestock and crop production, so from agriculture, from the agricultural sector, and then use those in addition to quantifying the climate change mitigation benefits, also the health impacts from diet, nutrition, and obesity at the national scale. The toolset is demand-driven, meaning that it is based on projections of food consumption, and the inputs that are required to use this toolset are the domestic food consumption, which is calculated based on population average, different food types, as well as data on food imports and exports, as well as food waste. And then it allows to calculate greenhouse gas emissions and air pollutant emissions, as well as these other health benefits. And they're separated into multiple modules. There is the food demand module that essentially transforms the inputs, and then modules on livestock and crop production and pasture lands, and then ultimately the human health impact assessment that links those to air pollution health impacts, as well as health impacts from diet, malnutrition, and obesity. The toolset can be found on GitHub at the address that is cited here below. And a global analysis of the application of this tool was published in 2021. And here I'm showing some of the results that were in that study. So we calculated global emissions and the resulting health burdens. And here you see the global agricultural emissions by greenhouse gas pollutant, ammonia, methane, nitrogen oxides, and then also a map on the right-hand side of ammonia emissions from essentially all countries in the world. And then those emissions were linked to impacts. And then here on the right-hand side, you see premature death from agricultural PM 2.5 emissions. And on the left-hand side, the health impacts from the dietary implication of that particular agricultural production. And you see that these are calculated in terms of malnutrition, percent overweight, and then what that implies to death. However, that tool set wasn't just developed to provide a scientific study, essentially, or a peer-reviewed article, but it was really developed for UNEP's integrated assessment of air pollution and climate change for sustainable development in Africa report, where it provided estimates on how long-term low emission policies across the continent of Africa would affect air pollutant or air pollution health impacts, as well as impacts on dietary health impacts. And so it supported kind of starting to devise a continental scale, long-term low emission or integrated low emission sustainable. And it wasn't just this tool that we provided for this integrated assessment, but rather we supported the entire modeling that took place under this assessment. And the model that was devised for this is the SEI Africa model. And the SEI Africa model really enables such an integrated climate and development assessment across the entire. In the African Union's Agenda 2063, there is a vision of the Africa we want that is described. And so the Africa model really provides the quantitative framework to evaluate how an ambitious development agenda for Africa can proceed at the same time as achieving these varied advances in different sustainable development goals, such as reducing air pollution, improving health and well-being, limiting impacts on local ecosystems, and helping to avoid climate change impacts. And so it provides the kind of quantitative prospective data that can inform planning by governments and other stakeholders, and it can be used for various options for enhanced synergies and to avoid different trade-offs. So the SEI Africa model is a Africa-wide model developed in LEAP with data for 54 African nations, covering the historical period 2000 through 2018, as well as projections out to 2063, matching the horizon of the Africa Assessment Report. And it provides annual results, but has particular focus on 2030, the SDG target year, in 2063. The whole continent is covered with national scale resolution of key variables, and the results can be shown for Africa as a whole, but also for individual countries or for various country groupings. And like is typical for a LEAP low emission model, it models all energy consuming and producing sectors, as well as key non-energy sectors, such as agriculture, industrial products and product usages, and solid waste. And it covers all long-lived greenhouse gas pollutants, as well as short-lived climate pollutants and all major local air pollutants. And there are 3 scenarios in this model. One is the baseline scenario, where Africa is actually heading under current policies. Then there is a short-lived climate pollutant scenario, which is focused primarily on avoiding these pollutants. And then the final, most comprehensive and ambitious scenario is the Agenda 2063 scenario, which builds on the short-lived climate pollutant scenario, but adds additional CO2 mitigation measures and really tries to address Africa's Agenda 2063 goals. And so the scenarios share the same population and GDP growth and urbanization projections, but they differ in ambition and policies that they explore. The Integrated Africa Assessment Report and the model were developed through a very various stakeholder consultations, and it really was tried to create a community through networks. More than 100 authors from 17 African countries were in the first author meeting, and several different organizations, intergovernmental and regional organizations were included. 20 African countries confirmed focal points in their ministries of environment. And then there were also various links made to global, regional, and national policy frameworks to really hook in this modeling assessment into the policy processes that are necessary to realize the ambition. The Integrated Africa Assessment provided various results, including that it showed that there were multifaceted development benefits from implementing the actions that were laid out, including preventing over 200,000 premature deaths per year by 2030, and reduce carbon dioxide emissions by 55% and methane emissions by 74% by 2063, and also improving food security by reducing desertification, increasing crop yields for a variety of staples. And so it showed that all of these benefits could be accomplished and come alongside important gains in mitigation. And here on the right-hand side in this graphic, I'm showing the annual temperature difference that would be accomplished through executing the Agenda 2063 scenario in comparison to simply pursuing current EAU policies. The SEI Africa model is not yet publicly available, but it will become open access in 2024. It will be published together with a major LEAP update, which is almost complete, and will be published in the first quarter of 2024. With the Africa model, which will be available from leap.sei.org, so where you also download your LEAP your LEAP software. It will be available both at the continental scale as well as at the national scale. And one will be able to download it and essentially look at it and modify it on your own desktop computer. The major LEAP update that we're planning for 2024 will also include energy system optimization modeling for multiple sectors. Currently, it's only possible to do optimization for a single sector. There will be the possibility to get cloud-based data directly into your model. Will support plugins and mini models. And there is a variety of other upgrades that will come with LEAP release. So Here is just a summary on how to access these tools. They are in large part already freely available. And you can take a screenshot of this slide, or we'll look at it in the recording later. And with that, I would like to move into the panel discussion. As I said before, I'm lucky to have with me today Eric, Kemp Benedict, Charlie Heaps, and Chris Malley, and they will be very happy to answer your questions. I see that there is already a number of questions in the chat. I'm just having a look.
I think we're pretty up to date on the questions, Charlotte. There was one question that did come up was whether the slides will be available, and whether you could maybe post a link to them in the chat.
Yeah, they're not yet available, but we can publish them when we publish the webinar also. When we publish the recording, we can also add the slides. Is there any question that you picked out that you would like to answer verbally as well, in addition to responding in the chat already?
I just got one that I could respond to live.
Go ahead.
Okay, it's a question about what does the convergence condition mean? What does that mean in the integrated LEAP AMES simulation? What it does is it compares result values for variables that are being passed to LEAP from AMES, and it looks at the maximum percent deviation from one iteration of the run to the next, and asks that be below a threshold that is set by the user. So it's a convergence in the result values. Typically that happens after 2 to 3 iterations.
Thank you, Eric. I thought that maybe you could also speak a little bit about how the development of these tools came about. We've already seen in the chat that people are saying these developments were much needed. Maybe you can comment a little bit on whether they were demanded by national stakeholders, or whether you proposed them to add them to particular policy processes that you were involved in. Chris, do you want to start?
Sure. Hi, everybody. It's nice to see some familiar faces in the attendees. So with the AgHealth tool, one of the questions that Dr. Amrit asked was whether it links to LEAP IBC, and I think the answer to that gives a good sort of overview of how the development of AgHealth came about. So 8 years or so now, Charlie and colleagues here in York began talking about LEAP IBC to be able to integrate health impacts or health implications into your scenario analysis. AgHealth really came out of that as an extension to the health impact functionality within LEAP sort of architecture. So AgHealth is not within the IBC module. The IBC module helps to quantify the impacts on health of exposure to air pollution. So AgHealth can be an input to the IBC calculations in LEAP in the same way that your energy emissions analysis or your waste emissions analysis can be an input to the IBC to calculate the number of premature deaths from air pollution exposure. But having gone through that process of understanding how to quantify health impacts from exposure to air pollution, we realized that there are a whole range of health risks that are impacted by different emission scenarios that you might be thinking about. So in the agriculture sector, there are quite a few health risks that are impacted by food consumption or lack thereof, and the production of that food. So we have the air pollutants that are emitted when we produce our food, either from burning of crop residues, from applying fertilizer. But on the consumption side, there are also health risks from malnutrition, from obesity, and from specific dietary risks, eating too much red meat, eating too few fruits and vegetables, for example. And so what AgHealth really tried to do was to integrate a broader set of health risks into that scenario analysis. But it really came from the experience we gained in developing IBC and understanding how those health calculations can be developed. And then on the FOLU tool, that really came from our experience of working with countries on updating their nationally determined contributions, where the forestry sector was often one of the sectors with the least sort of convergence of emission results and the least amount of sort of transparent information available. So the FOLU tool is not trying to do something particularly fancy. It's just faithfully representing the IPCC methods for the forestry sector. But for example, when we were working with the Ministry of Environment in Nigeria, when they looked at the previous estimates of emissions from the forestry sector, there was an order of magnitude difference. It was either 30 million tons if you believed their REDD+ reporting, or 300 million tons if you believed the greenhouse gas inventory in the national communication. Unfortunately, those estimates were done by different groups with different levels of transparency in the terms of the data that was used. And so we developed the FOLU tool so that there was a set of transparent Excel spreadsheets where you could enter your data. So even if you don't have the best data for the forestry sector, the calculations that you've done to underpin that the emissions in that sector are clear to everybody and can be updated over time. So that was the genesis of the FOLU tool.
Thank you, Chris. That's super interesting. Eric, do you want to speak a little bit about how AMES came about and how you've been applying it?
Certainly. It started off with my just pointing out to a partner that it's possible, it would be possible to link in some input-output type tables to LEAP. And then that was it. It was a presentation, but they came back and requested it, a dynamic type of link between LEAP and input-output, so that it's more of a dynamic model, not just static input-output tables. And so that got AMES development started. But I would say there's been a general demand for more link to the rest of the economy. If we pursue this energy policy, what are the implications for the rest of the economy? That seems to be a question that often arises. So we saw that there was a more general demand, and so we put more resources into developing AMES to make it more applicable to more countries. And so now it's quite a general model. As I explained in a question in the chat, you should be able to adapt it for many economies. The main constraint is on the availability of supply and use tables, but those are available for many countries now. So it should provide a basis for building an AMES model. Thank you.
Thank you very much, Eric. And Charlie, do you want to talk a little bit about the Africa assessment model, since it's bringing together at least some of these aspects?
Sure. So the Africa model came about initially based on a request from UNEP and the Climate Clean Air Coalition to conduct an integrated assessment of kind of like development, climate, and air pollution scenarios to examine sort of what measures might be used and to examine where there might be sort of co-benefits between sort of climate and air pollution action, as well as sort of think about development implications. So as a result of that, we developed the Africa model to sort of help address and look into some of those questions. One of the interesting things about the model is that it's, even though sort of a continent-wide scale model, it does have this sort of national scale resolution. So aside from sort of making the model itself available for Africa as a whole, we'll also sort of slice it up into sort of national scale models and to make those models available to anyone who wants to use them. Basically, it's going to be sort of an open source, open access, freely available model. As I noted in the Q&A, the models will be available on the LEAP website. We're still doing a bit of polishing on them, still sort of adding a bit of documentation for them, but they will be available basically at the same time as we release the new version of LEAP at the beginning of next year, sort of early 2024. And there'll be sort of a page on the LEAP website where you can access them. So please keep an eye on the LEAP website, leap.sei.org, for those things will become available there at that point.
Thank you, Charlie. I wondered whether any of the stakeholders that you worked with, either of the three of you, how they kind of responded to the results that you were presenting. And I'm thinking specifically about the results that didn't pertain to climate mitigation. Did it change the type of communication they produced or the decisions that they made? I think that's very interesting.
I mean, I can say for the Africa model, it's all, the scenarios that we sort of produced in that model are not sort of SEI's vision of what Africa should be doing. The sort of the direction of the scenarios and really detailed validation of the different measures that we looked at were very much driven by a stakeholder process. So it was a sort of it's very much the story is sort of written by African experts. So we were just sort of putting their story into LEAP, basically. They were telling us the story and we were sort of transposing that into LEAP. So so the results coming out of it do sort of give some idea of what sort of African experts think is possible in terms of how far certain measures can be pushed. How realistic those measures are, and then you do get a sense of the sort of directions that the continent might be going in and what it can sort of realistically do to address some of the air pollution climate challenges. I'm not sure if I answered your question exactly there, Charlotte, but that's the way the storylines evolved in the model, and that's kind of method that we really like at SEI. We like to sort of only be sort of the facilitators, but to allow the stakeholders in different regions to actually be sort of in charge of the sort of stories that are being told in these models.
And from what I understand, the Africa assessment is kind of in a slightly earlier phase, maybe in uptake, right? It's like it's an initial assessment that hopefully will be taken on by national stakeholders. I guess, Chris, in your work, you were in some sense involved in a slightly later stage of implementing policy. How was it when you presented results that didn't just protection these NDCs, but also to sustainable development, that transform how that analysis was communicated or adapted?
Yes, I think so. So the example that I think where the FOLU tool has been most successfully applied is in Zimbabwe. And I think there's two aspects of that application and consideration of SDGs that are sort of useful indicators of the potential of these tools to inform decision-making processes regarding climate change and development. The first is that in 2015, Zimbabwe's NDC committed to a third reduction in emissions only from the energy sector. So it just considered energy sector emissions. In 2021, they submitted an NDC which committed to a 40% reduction across all sectors. One of the reasons for that is that within the greenhouse gas mitigation assessment that was undertaken by the Climate Change Management Department in Zimbabwe, they were, number one, able to quantify the emissions coming from the forestry and other land use sector, as well as agriculture and waste, but also represent mitigation actions in the forestry sector from their National Development Strategy. It's called National Development Strategy 1. And because those measures are in the National Development Strategy and we're able to quantify their reductions, there was an easy sort of process by which those additional emission reductions and that more ambitious target could be committed to, because you had that clear link, the measures in the National Development Strategy. Using the FOLU tool, we know how much greenhouse gas that could reduce, and therefore we feel comfortable increasing the target. The second thing that I think is relevant in Zimbabwe is that in addition to looking at greenhouse gas reductions, we applied a lot of these methodologies and tools to quantify broader sustainable development goal implications. And the impact of that is that when you were presenting the impact of Zimbabwe's climate change plan, you were not just, communicating that Zimbabwe could achieve, being a good global citizen of reducing 40% of its very small, global contribution to greenhouse gas emissions, but suddenly that plan is shown to be able to avoid 1,000 premature deaths per year, most of them children, from improved household air pollution, from improved air quality, from improved road safety, things like that we haven't talked about in terms of these tools looking at health. So suddenly you shift from being a climate change plan to a public health plan. And I think that brings on board a broader coalition of actors who see this plan as being relevant for them because there are benefits that Zimbabwe can achieve itself.
And do you see, I guess this is an open question, and I'd also be interested to hear Eric on this. Do you see that there is kind of a shift in the debate at regional or national levels around climate mitigation planning and how it should be more integrative with other development goals, including those of the economy? I mean, I think you already hinted at this, Chris, that achieving climate mitigation is not necessarily the top priority for all countries, but some of these other development goals are, such as economic development. So do you see kind of a shift in the way that debate is being led?
Do you want me to go first? So I would say yes, to some extent. So my main area of interest is air pollution, and we did an analysis of NDCs that were submitted when the Paris Agreement was signed and that were submitted during COP26 in Glasgow. And the number of countries that consider air pollution and their health impacts more than doubled in that time period. So there's definitely a shift towards considering some of these development goals that are achieved locally compared to when the Paris Agreement was signed. I think the big barrier now is actually funding the actions that can achieve those reductions. So there are many countries that have shown how you can consider these development impacts in your climate change plan, in the report that you submit, but actually being able to show that in doing so, that can mobilize more funding and lead to more projects being implemented, I think is the sort of link in the chain that's not quite there yet.
I can just add something to that as well, Charlotte, which is, when we're helping countries do these mitigation assessments, we're not setting any targets for countries. We're helping countries think about what targets they might be comfortable with. And even though there's a huge new interest in renewable energy efficiency, and even there's a lot of evidence that those policies are cost beneficial over a long period, there's still very, most energy efficiency policies are still very capital intensive. So you do need sort of the upfront investment in order to sort of unlock the benefits that you get from those policies. So I think for all developing countries, that's like a really key question, is where is the financing going to come from to pay for those sort of upfront investment costs? even though in the long run they might be cost beneficial. So that's sort of a real question that a lot of countries are facing, is just sort of, what does good energy policy look like for my country? And for sure, energy, having a good energy policy is absolutely crucial for development. But how do you get there? How do you unlock the financing to enable that? So I think, the more that the tools can really get down to answering those questions in quite a bit of detail, and can help the countries really set out very sort of credible, detailed pictures of what their financing needs are, then that is going to sort of move the conversation along with the international community about sort of what the needs are for developing countries to sort of help finance these transition pathways that everyone's so excited about.
And
I let you go, but I just want to say that if anyone in the audience would like to ask a question, you can also raise your hand and we'll open the floor to you.
Thank you. Yes, we have been answering questions as they've appeared in the Q&A, but also you can ask questions live, as Charlotte just mentioned. Yes, on the economy, the typical questions are more about the impacts of energy expansion plans or energy transition plans on the rest of the economy. Do they have an overall beneficial effect? Does it not make that much difference? And importantly, does it add to employment? And so this is what we focused on. Does it have a general stimulating effect or more dampening? And so that's it's less on the long term and it's more on the short term impacts, because these are questions that are often raised outside of the energy ministry, asking about what might we see as we implement this, what challenges could arise, or benefits could emerge. And so that's been the main sort of question being asked. And so it's less a go, no go, a question of do we do this or not, and more a question of what could we expect to see if it were implemented. And often it has a stimulating effect. Thank you.
Chris, you just got a question on inputs to AgHealth and IBC. Do you maybe want to answer that question now as well?
Yeah, absolutely. IBC requires a leap analysis with emissions that quantify the air pollutant emissions in a particular country. It then takes those and combines them with health statistics, so baseline mortality rates, the population in different age categories that are exposed to air pollution in a country, and combines those together to estimate how many people are dying prematurely from that air pollution exposure. With AgHealth, you require data to be able to characterize the emissions coming from the agriculture sector. And we start there with the national diet. So understanding the percentage of the national diet that is made up from, staples like wheat, rice, how much is made up from meat, etc., etc. You then need to characterize your livestock production system, so the herd characteristics, the average weight of animals, the replacement rate, things like that, the composition of the feed, how manure is managed, and statistics on your crop production system. So how much inorganic and organic fertilizer is applied to your fields, whether your rice is managed in paddies or rain-fed, how that's all managed to give you your estimate of your agricultural emissions. For then the health side, you need a few more statistics on baseline mortality, because there's a broader set of diseases that are considered in AgHealth than just those related to air pollution. So there's a few more health statistics that are required. The good news for AgHealth is that it was designed and set up so that there is a default value for every number. Most of them come from the FAO stats statistical database on agricultural statistics. So for most countries, there is already a model set up in AgHealth using FAO data, but of course, all of that data can be changed and used with national statistics that better represent diets or livestock or crop production. But you can choose which ones to change and then just fall back on the default if you'd like to.
Thank you. With that, we're also reaching the end of the hour, and there are no open questions left. So I think with that, we can end on a happy note. I'm really glad to have seen so much interest in these webinars. It's been great that people have been joining and participated so actively. So I just finish on that note. Thank you for participating. As I said earlier, the recording will become available in the next couple of weeks on the LEAP website, and we will send out a follow-up email to everyone registered with information once that happens. And you also get the slides there. And then in the next year, the Africa model will become publicly available. So keep a lookout on the LEAP website for that. And with that, thank you. And thank you to the panelists for joining at sometimes rather odd hours of the day to make this possible. And I wish you a good rest of your day.
Thanks, everybody.
Bye all.
Thanks, everyone.